Hi, students. I'm talking to you now about the first question in your AP Classroom Assignment 61. It's two FRQs, and I'm talking about the first one. So we've got a piecewise function here defined for all real values, but it's broken up into these four chunks. And we're going to look through the problem. So for what value of k, so I want to find a value because it says what value. So that's telling me it's a singular value. So what number, if any, so maybe there's no solution, is f continuous at x equals -2? Well, to be continuous, we know that the limit as x goes to -2 from the left of f of x has to equal the limit as x goes towards -2 from the right of f of x, and that has to equal the f of -2 value. So let's first look at these limits. So the limit as x goes to -2 from the left of f of x, so -2 from the left, that's going to be this set up here. So I'm going to evaluate that function. It's going to be -2 squared plus k times -2 minus 2 over 3 times -2 squared plus 4 times -2 plus 3. So that's 4 minus 2 is 2 minus 2k over let's see, that's going to be 12 minus 8 is 4 plus 3 is 7. The limit as x goes to -2 from the right of f of x. So I'm looking for values of x greater than -2. So that's in this region. So I'm here. So that's going to be -2 cubed plus 2. -8 plus 2 is -6. And this is less than or equal to -2, so this is also the value of f of -2, because that's where this function evaluates for -2. So now, to be continuous, I need -6 to equal 2 minus 2k over 7, so I'll just solve that. I get -42 is 2 minus 2k. Oops, that's a positive 2. So then I would get 44 over there. -44 divided by -2 is going to give me positive 22 as my k value. So that's what I need to be continuous. Let's look at what the AP says for the scoring guidelines. So if we look down here, part A was worth 3 points. So you had to have the limit as x goes to -2, the limit as x goes, -2 from the left, -2 from the right, and justify of equating with f of 2. So you can see how I did that. I did it sort of in these steps. I also had this sentence somewhere that it's continuous if that was true, and then had the value of k equaling 22. All right, let's look at part B. Part B says, what type of discontinuity does f have at x equals 0? Give a reason for your answer. Well, discontinuities are when this is not true. So I could have either a removable discontinuity, I could have a jump discontinuity, I could have an asymptotic discontinuity. So let's analyze our function around 0. So I'm going to take all this and move it so that I can look at the screen at the same time. So let me take that and drag it down here. Okay. So now we're looking at part B. So I'm going to look at the limit as x goes to 0 from the left of f of x. So that's going to be in this region here, and I'm going to get 2. The limit as x goes to 0 from the right of f of x. So that's going to be this side here. So I'm going to get 2 times e to the 0, which is, of course, e to the 0 is 1. 2 minus e to the 0 is going to be 2 minus 1. So I'm going to get 2 over 1, which is 2. So this tells me that my limit exists of f of x is 2. Let's figure out what f of 0 is. Well, I'm told that f of 0 is 0. So if I graphed this, then I'm going to have some sort of function that looks like it wants to go through the point 0, 2, but then jumps to the point 0, 0. So somewhere in my graph, it's going to look like, let's see, on this side we had x cubed plus 2. So it's coming sort of from the left, I'm coming this way towards 2. Then I'd have an open circle. I have this function. I don't know what that's going to look like, but it was approaching 2 somewhere. But then the actual point at 0 is down here. So this is a point discontinuity. So I could put in a does not equal there to help show. But I do have a point at 0, 0. So I have a point discontinuity. Let's see what the AP says. So for part B, we've got 2 points, one for finding both of those limits, one for the answer of removable discontinuity, point discontinuity. Either one of those would be acceptable. All right, let's look at part C. So part C here, find all horizontal asymptotes. So a horizontal asymptote like this is my behavior. So HA is behavior as x is going to plus or minus infinity. So again, I'm going to slide this down. So really what I'm looking for here are my limits. So my limit as x goes towards infinity, well, that means I'm looking at this function of 2e to the x over 2 minus e to the x. Well, that's going to end up creating, so looking at that separately, I would have infinity over negative infinity. Therefore, I can use L'Hopital's rule. And when I use L'Hopital, then I'm going to get the limit as x goes to infinity of 2e to the x over, that becomes 0, negative e to the x. Well, those e to the x's now cancel, and I get negative 2. Therefore, I have a horizontal asymptote at y equals negative 2. Let's look at my behavior for x going to negative infinity. Again, I lost that exponent. All right, so now x going to negative infinity, I'm looking at this function. So my limit as x goes to negative infinity of x squared plus x kx minus 2 over 3x squared plus 4x plus 3. Well, this is a rational function. I have same power top bottom. So the rest of this stuff doesn't really matter. This is going to look like x squared on the top and 3x squared on the bottom. So that's going to simplify to 1/3. So my other horizontal asymptote is y equals 1/3. If I go and look at the scoring guide, you can see that they actually did more work they factored out an x squared and then said those x squareds would cancel. And then they took the limit as x goes to infinity. Well, as x goes to infinity, this is going to be 0, 0, 0, 0. So you're left with just 1/3. But notice they say here, students do not have to show the factorization to earn that second point. So if you can recognize that this is just a rational function that has same power top bottom, then you can know straight away that its limit is going to be 1/3. I hope that was helpful. As always, let us know if you want more help on things, and we're happy to help you.